Yeah. So next we move on to how blockchains work, right? So I'll say without any reservations that, I mean, any kind of blockchain that you've ever heard of, you know, whether it's Bitcoin or some altcoin or Ethereum or Tezos, they all have some of these components. In fact, all of these components are available in them, whether directly or indirectly, whether they like it or not. And so this summarizes in one screen how blockchains work, and that is it, right? So let's start with the networks and nodes, right? So a blockchain is essentially a computer network, okay? So it's a network of nodes. So when we say nodes here, don't think too far. Nodes are just computer servers that participate in the blockchain network. Nodes can enter and leave at any time, you know. So it's like that. Like, in fact, you can participate in any blockchain network with your laptop. I mean, but however, it depends on the strength of your laptop or something. Or you can use a strong server computer or something, right? The point is that a blockchain is a network, right? It is a network of nodes. However, these nodes communicate based on certain rules, okay? And that's what makes it a blockchain. And we'll get there. But basically, first of all, let me just even draw this. So we have nodes in our blockchain, right? Nodes, and nodes are server computers that participate in the blockchain. So very soon you get to know what I mean by participate. And these nodes, they talk to each other, right? They talk to each other. So it's kind of like, if you're familiar with network topologies, I don't know, this is what they call the mesh topology or something. I mean, any node, the point is that any node can talk to any node. I'm not good with remembering names, but that's it. Alright, so this node can ask this node for something, this node can ask this node for something, and by nodes I mean computer networks or computer servers. So we'll get back to that later. And then the next component is transactions and smart contracts, right? So let's say it's transactions. So transactions are broadcast to all nodes in the network. Transactions mutate the state of blockchain. So what is a transaction? So at a very basic level, all right, let me just use a simple example for what a transaction is. So a transaction, a simple example is, okay, I want to send this amount of Bitcoin from my address to this address. That is an example of a transaction. But a transaction could also be as complex as a smart contract. In fact, a transaction could contain anything, right? And the reason why I said transactions and smart contracts is that basically in recent blockchains we are seeing that transactions are kind of the same as smart contracts, because even in a blockchain, to send maybe money to someone from one address to another address, basically what you're doing is you're executing a smart contract, right? Yeah. So you're writing a piece of code that says this is the person who can get the money or something. For instance, in Bitcoin, to transfer money to someone is not as simple as say this person has an account, right? It's not as simple as say this person has an account and this B also has an account, and then I'm transferring money to be? No. And then it will deduct, and then it will add to be. No. The point is that, of course, they have an account. They have what we call an address, right? And everyone in the network has what we call a public key. Public key, usually denoted as PBK, and then a private key, right? Private key. Okay, so when I say you send money to someone's address, what I mean is you send money to. So an address is basically the hash, okay, of the public key. And if you are familiar with what a hash is, it's a one-way function, right? So it takes an input and it gives the same output for that input, right? But then also it ensures that when you immediately change the input, the output also changes dramatically, right? So an example of a hash is we have the SHA-256 hash and MD5. Yeah, so I'm sure you've heard of MD5. So there's this website hash. Right. So I just want to demonstrate what a hash is, right? So I mean, these are some of the things you need to understand when you want to do a blockchain or something like that, right? So there's a hello there. Ooh. Oh. I mean, this is not really there. I want. Okay. So hello, you see, and this is the hash, right? This is SHA-256 hash. Okay. Hello world. If I change even this to dot, if I add even a dot here, just notice what happens. Changes dramatically, right? So that's what a hash is. So it takes whatever you have here, which is looking nice, and then turns it to something which looks not like what you had initially, and you can't come back from here to here, right? So that's what a hash is. So it's a one-way function, right? You can go from your original text to the hash, but you can't go from the hash to the original text, right? So basically every account on, say, Bitcoin blockchain, and in fact all other blockchains have what we call the public key and the private key, and then the address is the hash of the public key, right? So the private key is private, and this is what you need to keep secret. So this is where you can hear people saying, okay, I'm keeping it on a certain device, or maybe I'm storing it on the cloud storage or something, right? The point is you need to keep this thing secret, right? Maybe people write it down and then they put it in their safe boxes or something. And anytime you need to make any transaction on the blockchain, you need your private key in order to make the transaction, right? But a public key, or maybe say the hash of your public key, is what is available for everyone to see what is it's available for everyone. So if you want to send money to someone, basically you are sending to the hash of their public key, right? Yeah. So, and what you are doing is that Bitcoin, how it does this is it writes a piece of code, right? And then this code, I don't know let me try to see if I can find it here for you. I feel like it's really interesting to see, right? Yeah, I found it. So here's it, right? So basically, sending money to someone, what is happening is this is the code you are writing for the person. You are writing this code, and then, so I mean, this is done automatically. You don't write it yourself, but basically, this is written, and it says op hash 160. So this is like operations on the Bitcoin blockchain, and this is what kind of like locks money into a certain public key hash, and the person who can get this amount or spend whatever is logged here is the one who has the private key, right? And so you can look at this and you can go and read more over there. Bitcoin is not in our focus now, but basically they go ahead to show you like what is happening, right? And it's interesting actually. So yeah, so it's not like necessarily like a debit and credit something. No, basically it's a smart contract. So this in itself is a smart contract. Yeah, just a little piece of code which needs to be executed, and then the output needs to be true. If let's say you have the private key, then the output will be true. If you don't have the private key, the output will be false, and it means you can't spend whatever money is locked up here, right? So that's what transactions and smart contracts. So a blockchain, a blockchain is, how it works is that nodes send these transactions to each other. These are little pieces of information, right? So let's say there's an outside user who wants to send money to someone. This outside user will instruct a node that, hey, I want to send money from my public key or my account to another account, and this node will then broadcast, right? It will tell the other nodes, so the other nodes will also keep it in mind, right? Then someone else who can also make the same request to this node, and this node has to broadcast. I mean, so that's how these nodes interchange information, and anyone can join this node, right? In this case, this user is not a node; it's just a user using one of the nodes, right, or one of the servers. It's like logging onto Facebook. When you connect to Facebook, you are connected to Facebook servers, right? But here, when you want to maybe spend on a blockchain, you are connected to all the servers on the blockchain. And the difference between what the Facebook example and this is that in the Facebook example, all the servers belong to Facebook, but in this example, the servers belong to different people, right? And even you yourself as a user can set up your own node and then start, receiving transactions and all of that. But to use a blockchain, you don't need to have a node yourself because there are other nodes set up, right? And so the question is, why would someone set up a node or set up a server just to run it on the blockchain? I mean, it costs money, so why would they do that, right? Yeah. So the next thing is, so when nodes like transactions are generated and are shared between these blockchains or these nodes, the next thing is consensus and blockchain creation, right? So let me clear what is here. No. So to block. So I mean that the whole thing is named after blocks. So I mean it's fair to think that that's an important part of this. So what is a block, right? So let's just visualize a block as a block, but basically it's just a collection of transactions, right? T1, T2, and then a whole lot of transactions come in play, right? Yeah. So basically, as we said, transactions, when a transaction is sent to one node, it broadcasts this transaction to the other nodes. So this guy says, hey, I want to send money to this person, right? So this node will broadcast it to all these nodes and say, hey, this guy wants to send money to this person, and this one also pass it along, and before you know it, everyone in the network knows. I mean, this would take some time, but based on network latency and all of that, but as time goes on, everyone will know. All right. So with transactions, like just single pieces of instructions, right? But the blockchain doesn't immediately, record transactions into its database. So you can think of the blockchain. What it does is, over a period of time, it collects all the transactions that have happened over that period of time and put them together. And this is what we call a block, right? So a block is just a collection of transactions. So in Bitcoin, for instance, it collects a block is created every 10 minutes, right? And part of the time is used to collect all the transactions, and then most of the time is used to compute a certain proof that indeed you collected the transactions. And so that's a consensus and block creation. And so I mentioned a certain proof, right? So in Bitcoin, we have this thing called the proof of work, right? So let's say you collect a certain amount of transactions in a block, right? Now, that's not the end of it. In the block itself, you need to find something called the nonce, right? N-O-N, the nonce. Sorry, N-O-N-C. And this nonce is just, think of it as just a random number, right? It's just a random number. And this random number, you need to find a random number here and add it to all the transactions you've had in such a way that when you hash this block, okay, you are going to get a certain value, right? Of course, and this value, when we convert them to zeros and ones, so it should have a certain number of zeros at the beginning, right? And the only way to do this is to find a random number, compute the hash, and then check if the number of zeros at the beginning satisfy the condition. So you can say, okay, when you find a random number and you compute the hash, we need 5 zeros at the beginning. So until you do that and you find 5 zeros, you are not going to, you don't have the correct nonce, and you need to keep on doing this. And apparently this is actually a difficult task, and this could take like 10 minutes for one of the servers to find it actually. But this actually takes 10 minutes because there are a lot of servers working trying to find the nonce, right? So if there are a lot of servers trying to find the nonce, by almost someone will find it in 10 minutes. But if there was only one server, it would take it the rest of the world to do that, right? So basically, that is how, like, once you find the nonce, then it means that you created this block, and then you can share this block with other nodes, and then what they'll do is to add it to the blocks that they already have, right? And this continues. So after a block is created, and then all the other nodes will start working on a new block, and then someone will find the nonce, and then they'll start working on a new block, and then it keeps on going, right? And so that's why this is called a blockchain, right? It's because when I get a new block, I add it to the old block, and then I get a new block and I add it to the old block, the new block, and I add it to the old blocks, right? And they are added in such a way that if you kind of remove this block, right, then this block will become invalid, kind of. So we don't want to go deep into that. So basically, this is what is called a proof of work, right? Looking for this hash so that the number of leading zeros is a certain specified number. and based on that number, this if we when you increase the number of leading zeros, the time it takes to find this number also increases. Okay, so yeah, so that is how it's done in Bitcoin and Ethereum, and this is what is called the proof of work, right? So POW networks. So in Bitcoin and Ethereum, the way blocks are created is you have to find these nonce such that when I hash the whole block, I'll get a certain leading number of zeros, right? And this is what is called the proof of work, and it's nice. But in Tezos, it doesn't use the proof of work. It uses something called the proof of stake, right? And I will go into this proof of stake later. Okay, so I mean, that's now we understand this. And then the last thing is the protocol upgrade and governance. So a blockchain is basically made up of a set of protocols, right? So like, how do we determine that a transaction is valid, right? So for instance, someone wants to send money from one address to another address. I mean, the way we determine is we see if the money there, where the addresses they are trying to send the money from, has the balance necessary. So for instance, if this address wants to send a certain amount X, right, what we do is we'll check the address A to see if indeed it can send that amount X. So that's one way of making sure that a transaction is valid. Another way is to so that's one of the rules. I mean, it's a basic thing, but another thing is that it takes, for instance, in Bitcoin, it takes 10 minutes. It's supposed to take 10 minutes, and the system has been coded in that way that it's supposed to take 10 minutes for a new block to be created, right? So if it doesn't take 10 minutes or it takes less time, then the system itself will adjust itself so that next time to take 10 minutes. And this is like the protocol, right? So it follows a certain set of protocols, like what should happen in which case and whatever. So if you remember the example I made with Bitcoin Cash and all of that, that because Bitcoin takes 10 minutes, some people said, all right, we want to speed it up, and yeah. So you should also notice that Ethereum takes like 17 seconds approximately to create a block, right? So it is that fast, even though it's also using proof of work kind of block creation. So so the at some point we might want to change the rules. For instance, in Bitcoin, at some point people want to change that, okay, instead of taking 10 minutes to create a block, we want to take less than that to create a block, right? And what happened was that some people didn't understand and some people understood, and what happened was that the network splitted, and this is what is called a fork-based mechanism. Fork as in FORK, right? So if you are familiar with open source project, when someone forks a project, basically they make a copy of it and then they start writing their own, adding their own stuff to it, right? So this is what happens in blockchains like Bitcoin and Ethereum, right? So once there's a misunderstanding, right, the what happens is that people just split, go their own ways, right? So in the case of Bitcoin and Bitcoin Cash, they both went their own ways. Bitcoin kept on being Bitcoin. Bitcoin Cash say, hey, we want faster transactions, and so they made a fork of Bitcoin, and then they reduced the block creation time so that the transactions would be fast, right? And Ethereum itself also has very fast transactions, right? And it also does this. So Ethereum also kind of, you could say, it also came out of the frustrations of slow transactions in Bitcoin, and then they decided to solve this problem. And also the fact that Bitcoin didn't want to improve it on its smart contract platform, so Ethereum decided that no, we want to build our own stuff here, right? So but in Tezos, okay, so one of the things you realize in Tezos is that Tezos has actually solved this problem in such a way that instead of the network being splitted, or instead of people going their own ways, we actually vote on ideas, right? And this is what is called on chain. And we vote on ideas. Okay, this we want this, we want this, we want this. We all come together, we vote, and then the best ideas win, and then those are the ideas that we implemented into the network, right? So we in the end will not have someone going their way to go and fork, because the more there are people leaving the original thing to go and do their own thing, the less like valuable this original thing becomes, because then like the people who would have been there and have now left, right? So yeah, so that's that for how blockchains work. So Bitcoin, this is the very first cryptocurrency platform, the inception of which introduced blockchain technologies. And Bitcoin is, as we've already seen, is very highly has a very high financial value. The block creation speed is low, right? And then the protocol upgrade and governance is poor. I mean, anything that's fork based that uses a fork based mechanism is poor, because I mean it keeps on splitting the network, people keep on leaving, and yeah, so it's not good for anything. So but Bitcoin itself is very valuable, and yeah, but so this is just like a strength kind of thing. So the next thing is Ethereum. Ethereum also has some kind of good financial value. The block creation speed is not as good, but definitely faster than okay, so this should have been this, and this should have been this. Anyway, it's definitely faster than Bitcoin, don't get me wrong, but the upgrade mechanism is the same thing as Bitcoin uses, right? So it's not that good also, but it's faster than Bitcoin. It takes about 17 seconds to create a block. So can you imagine that? That is really, really fast, right? Yeah. And because I'm a Tezos guy, of course, anything I say here, I'll say in favor of Tezos. So yeah. Anyway, then the last Tezos, it takes a lot of lessons from its predecessors. So its protocol upgrade and governance mechanism is really good. Its block creation speed is fast, right? It's faster than Ethereum. So, but you should know that Ethereum is also very fast, right? But I mean, the transaction speed is faster than Ethereum. So Tezos has about 40 to 50 transactions per second, and Ethereum will have about, say, yeah. So yeah, our next stop. Finally, we are here to the main talk of the day, to the main topic of the day. That's a smart contract, right? So yeah, let's get started with the smart contract.